Earth was not born in silence. It was born from a crash. A wound of light tore through the primordial darkness and the sky turned to fire. From that collision, a glowing ring wrapped around the world. From that scar of stone and flame, the moon was born. This is not the beginning you imagine. It is the sound of chaos becoming order. It is the birth of a home. And much later, on this home, life arrived. Because that rhythm, water, light, time, made the first breath of the world possible. At the beginning, there was no sky to look at. There were no stars, no space to place them. There was a silence so dense it had no name. Then something happened, an ignition. Time began to flow. Space began to expand. Light was born. From the universe's first breath came the simplest ingredients, hydrogen and helium. Much later, in the darkness, the first stars ignited, enormous, brief, fierce. Inside them, fire forged new letters of the cosmic alphabet: carbon, oxygen, silicon, iron. When these stars died, they exploded, scattering their ashes everywhere. Those ashes are the dust we are made of. Seas and mountains are dust that will one day become our cloud. Before that ignition, science can only whisper. Some speak of fluctuations in the vacuum. Some imagine infinite universes. Some see the hand of God. What we can say is this: everything we know was born from a real beginning and from dead stars that left behind matter and memory. From that memory begins the story of Earth. Before Earth, there was a cold cloud of gas and dust, material expelled by dead stars and ancient explosions. Something disturbed that cloud, a nearby stellar blast or the passage of a shock wave. The cloud began to collapse towards its center. At the center, the young sun ignited. Around it formed a flat disk of dust and fragments. This is where Earth was born. In that disk, dust did not remain dust. Grains collided. Some bounced away. Others stuck together thanks to weak forces. Over time, they became pebbles, then rocks, then ever larger bodies. When a body became massive enough, its gravity pulled in more material, an avalanche effect. In a few tens of millions of years, the seed of Earth grew into a protoplanet. Each impact released energy and heated the body. Heavy materials like iron and nickel sank towards the center. Lighter materials remained above. This process is called differentiation. A metallic core formed at the center. Around it, a rocky mantle. Above that, a thin crust. This separation explains two fundamental things: why we have a magnetic field and why the surface is not metallic but made of silicate rocks. When Earth was already large, another young planet entered its orbit, almost as big as Mars. We call it Theia. The collision was not head-on, it was oblique. The impact tore material from Earth's outer layers, vaporizing part of it and throwing a belt of incandescent debris into orbit. Gravity gathered that debris. In a short time, perhaps weeks or months, it compacted into a single large body. The moon was born. The newborn moon was much closer to Earth than it is today, perhaps 15 to 20 times larger in the sky. Imagine a huge red moon filling half the night sky. Slowly, it moved away to its current distance. The moon stabilized Earth's axial tilt. Without this stability, the climate would have oscillated chaotically. With the moon, the rhythm of the seasons became more regular. This was decisive for the future of life. After the impact, Earth's surface was an ocean of magma. Heat came from three sources: impacts, compression, and radioactive decay. Above the magma formed a primitive atmosphere of water vapor, carbon dioxide, nitrogen, sulfur, and other gases.
It was not breathable, but it played a key role. It trapped heat and slowly released it into space. Earth began to cool from the outside inward. Crusts formed and were constantly broken by new impacts and eruptions. When temperatures dropped enough, water vapor condensed. An age of extreme, prolonged rainfall began. Rain fell on glowing rock, evaporated, fell again, over and over, until water could remain liquid on the surface. Thus, together with volcanic gases and a small amount of water delivered by hydrated asteroids, the first seas formed. They were not blue, they were dense, rich in dissolved metals, but they were true oceans. For the first 100 to 200 million years, remnants of the protoplanetary disk continued to strike Earth. Not a single storm of rocks, but a long phase of declining impacts. Large impacts vaporized portions of ocean and crust, but in between impacts, the surface recovered. The crust thickened. Water returned to the basins. This alternation of destruction and rebuilding mattered. Each impact delivered useful elements like carbon and nitrogen. Each cooling phase created new chemical environments. Meanwhile, deep below, the rotating metallic core generated a magnetic field, a shield that deflected much of the solar wind and helped prevent the atmosphere from being stripped away. Earth was no longer just a world of fire and stone. It was becoming a stable system where liquid water and solid rock could coexist beneath a protected sky. The crust welded into protocontinents. Mountains rose, rivers eroded them, sediments flowed to the sea. Oxygen was poisoned for many cells. Many died. Others learned to use it. Those who did gained far more energy per unit of food. A harsh selection, but one that opened a powerful path. Some cells engulfed others that produced energy. The partnership stabilized. They became one. Larger, organized bodies emerged. With more energy, cooperation paid off. Cells stayed together, taking on different roles. Bodies formed. Soft creatures appeared, filtering food from the sea. Then came predation. From that moment, an arms race began. Muscles strengthened, senses sharpened. Light-sensitive spots curved into cups. Openings narrowed. Natural lenses formed. The first eyes emerged, enough to chase or flee. Defenses followed. Shells, spines, armor, burrowing, camouflage. Not sudden leaps, but long sequences of successful attempts. Life diversified rapidly. Skeletons formed, muscles strengthened, coasts shifted as continents moved. Later, when cycles stabilized, plants left the water. Fish ventured onto land. Fins strengthened. Air sacs became lungs. Amphibian-like creatures emerged. Later, eggs evolved shells. Life fully claimed the land. This was not a jump, but a march of millions of steps. This story remains written in stone. Ancient layers, crystals, sediments, planetary fingerprints. From the first droplet to the first cell, from one cell to organized bodies. Each step required a boundary, energy, and imperfect copying. With enough time, the simple becomes capable. It began with a wound in the sky. That wound gave birth to the moon and set the world's rhythm. Within that rhythm, Earth learned how to protect the fragile. And so began the long chain we call life. This is why today this planet is a home. We have told the how, matter igniting, planets forming, water remaining. The evidence comes from rocks, light, and time. Yet one question remains unanswered. What is the energy that truly moves space, matter, and life? Why these laws and not others? Science takes us as far as data allows. Beyond that boundary lies mystery. Some call it God. Some await new answers. Some see both. And it is there that our journey continues, where what we know ends and what we can still discover